Let's revise the basic concepts from ratio and proportion. Now, we know that ratio is used to compare two quantities. For example, if you want to cook rice, then you can take 1 cup rice and maybe 1.5 cups of water. But if you want to make 2 cups of rice, then how much water do we need? In that case, we have to look at what's the equivalent ratio. So if we just double the quantities, we'll find that for 2 cups of rice, we'll need 3 cups of water. If for 1 cup of rice, you needed 1.5 cups of water. So if we equate two or more equal ratios, we call them a proportion. So for many practical purposes, we might need to maintain the proportion. Now let's look at some more examples of ratio and proportion. Let's say that we have a ratio 2:3 and we have another ratio 4:6. So both of them are actually equal. So we will say that this entire thing 2:3 equals to 4:6. This becomes a proportion. Another way to write the proportion is by using the double colon symbol. So 2:3 proportional to 4:6. Or I can also write ratios in the fractional format, where I can say 2/3 is equal to 4/6. Now if I cross multiply, I will be able to say that 3 into 4 is equal to 2 into 6. So that is always true in case of a proportion. So suppose here we had taken two equal ratios. So we have four numbers which are in proportion. The numbers are 2, 3, 4 and 6. So within a ratio, I have two numbers, the left and the right one. So the first term and the second term. Now if I have a proportion having two equal ratios, I have four numbers or four terms which are in proportion. So the first number is the first proportional. The second number is the second proportional. Similarly, we have the third proportional and the fourth proportional. The first and the fourth in this example are extremes, and the second and the third are called the mean terms, extreme terms and mean terms. So we will see that product of the mean terms will be equal to the product of extreme terms. That's true in a proportion. Another type of proportion, for example, if I see 1:2, it's equal to 2:4, then I see that the mean term is the same. The second and the third term are the same. So I will call them the mean term or the mean proportional, and then 1 and 4 become the extreme terms. The number 1 in this situation is the first proportional, then we have 2 as the mean proportional, and 4 here will be the third proportional. We don't have a fourth proportional here because the mean term is repeating. So again we will say that the product of the means is equal to product of extremes. So we will have 2 into 2 is equal to 1 into 4. Or if I had stated the proportion in general, it's A is to B equals to B is to C. So we will have B square equal to A into C. The square of the mean term is equal to the product of the extreme terms. Now the second kind of proportion that we see here, 1:2 equals to 2:4, this is known as a continued proportion. We can have any other proportion in general where we have four terms which are different, but in case the mean term is the same, it becomes a continued proportion. Now let's look at some properties of proportion. So if there is a given proportion, for example, A is to B is equal to C is to D, this is a given proportion, then we can change the terms in the given proportion so that it results in another proportion. For example, if I take the reciprocal on both the ratios, the resulting two ratios are also in proportion. So I will say B by A will also be equal to C by D. That is known as invertendo. Or I could have interchanged the mean terms, and then the result is again a new proportion. For example, if I had started with a is to b equals to c is to d and I interchange the mean terms, then a is to c will be equal to b is to d. So that property is known as alternando. And if I had added both the terms of the ratio and that becomes the first term of a new ratio, then again those two ratios will be equal. For example, if I had started with the ratio a is to b is equal to c is to d, then a plus b by b will be equals to c plus d by d. This property is known as componendo. Or otherwise, again, if I had started with my original proportion and if I subtract the two terms of a ratio and that I say is the first term of the ratio, again they will form a new proportion. So I will say a minus b is to b is equal to c minus d is to d. That is known as the property dividendo. If I combine componendo and dividendo, for example, if I say this is equation 1, this is equation 2, and if I divide equation 1 with equation 2, I will get another resulting proportion which will tell me that a plus b by a minus b is actually equal to c plus d by c minus d. So given my original proportion a is to b equal to c is to d, I can also conclude that a plus b by a minus b will be equal to c plus d by c minus d. So this is known as componendo and dividendo together. Now if I had taken an example, let's say that 3 is to 2 is equal to 6 is to 4. This was my given ratio. Then if I apply invertendo to this proportion, then I will get 2 is to 3 is equal to 4 is to 6, which is actually true. Or if I had started with my proportion and I am applying alternando, I would get 3 is to 6 is equal to 2 is to 4, which is also true. If I had applied componendo to my original proportion, then I will get 3 plus 2 by 2 is equal to 6 plus 4 by 4, which results in 5 by 2 or 5 is to 2 equals to 10 is to 4, which is also true. Or if I had applied dividendo, then I would get 3 minus 2 by 2, that's equal to 6 minus 4 by 4. So the resulting proportion would have been 1 by 2 equals to 2 by 4, which is also true. And finally, if I had applied componendo and dividendo to my given proportion, then I will get 3 plus 2 by 3 minus 2 is equal to 6 plus 4 by 6 minus 4, which will give me 5 by 1, that's equal to 10 by 2, and that's also true. So these are the 5 properties of proportion.